Yeah. Hi. Why are lightning super bolts more common over the ocean? Salt seems to be the reason why bolts are brighter overseas than over land. This article is from Hakai magazine, an online publication about science and society in coastal ecosystems. When marine scientist Mustafa Asfour made a tiny storm in a box, he stumbled on a possible solution to a long standing mystery. Why bolts of lightning are brighter over the ocean than they are over land. More than 90% of lightning bolts strike over the continents, but the lightning that strikes the ocean can be far more intense. Rare superbolts, for example, with flashes 100 or 1000 times brighter and more powerful than a regular bolt, are far more likely to hit the ocean. Exactly why, this is still under debate. As for Nawatu Ruppin Academic Center in Israel had set out to investigate how lightning bolts affect water chemistry. Instead, he discovered that, in the lab at least, lightning like discharges are brighter over salt water than over fresh water or soil. We were surprised, says atmospheric scientist Colin Price of Tel Aviv University in Israel, who was asked for supervisor at the time of the experiments. Everyone believed, including myself, that something in the thunderstorm controls the intensity of the flash, something in the cloud. But the study shows, says Price, that what lies beneath has a big effect on brightness. As for Storm in the Box was low tech. Yeah, you don't need a particle accelerator. Just a spark generator, a couple of electrodes, and a beaker of water in a dark wooden cabinet. When the flash discharged, it made a tiny audible crack as the air heated up. The mini bolts were about a million times less powerful than real lightning, but created a sap with the same light profile as a real spark, because it's a real spark. It's scalability, reproducibility. When Asfor and his colleagues first realized that saltier water seemed to be making brighter sparks, they went to the Dead Sea and brought back some water. Sure enough, that super salty water spurred a super bright spark. Asfor reran the experiment multiple times using freshwater, soil, and samples from the Sea of Galilee, barely salty, the Mediterranean, quite salty, and the Dead Sea, very salty. The results clearly showed that the saltier water, the beefier the bolt, discharges over Dead Sea water, which is about 680 times saltier than Galilee water, were nearly 40 times brighter. Flashes over Sea of Galilee were 1.5 times brighter than over wet soil. The team has an explanation. In water, salt splits into positive and negative ions that help conduct electricity. When lightning strikes, the more ions present, the more efficiently the electrical charge is drained from the cloud. That swift discharge causes a higher peak current and a brighter flash. University of Washington Earth Science professor Robert Holdsworth, who manages the Worldwide Lightning Location Network, says the research is a nice step towards showing that the salty oceans and seas could be responsible for more intense lightning on average. But, he adds, there's a big difference between the small scale lab study and actual lightning. There's a whole bunch of dynamic processes that aren't included. Last year, Holdsworth and his colleagues surveyed 2 billion lightning strikes recorded between 2010 and 2018 and mapped out 8,000 intense superbolts, the vast majority of which hit the ocean. The strongest superbolts were super concentrated in the Mediterranean Sea, with the distribution curving up past Spain and the United Kingdom to Iceland and Norway. They found smaller hotspots east of Japan, off the tip of South Africa and, surprisingly, over the Andes Mountain, the only terrestrial site. For such a common phenomenon, lightning holds many mysteries left to untangle. Scientists are still trying to work out whether measures of bolt energy, which is what Holzwell Super survey looked at, show the same trends as measures of total bolt brightness, which is what ASFOR was studying. Salt content can't explain the entire map of superbolts, but it might, for example, contribute to the hotspot over the salty Mediterranean. Hmm. The research also hints at a way that climate change might lead to brighter lightning bolts. Some patches of seawater, such as the North Atlantic, are getting fresher as ice melts, but others, notably in the subtropical Pacific, are getting saltier as evaporation ramps up under hotter air. Ocean acidification is also adding hydrogen ions to the water. Also, those extra ions mean climate change might spark more intense lightning superbolts. Yeah, let's go over to windy. And here we are, Mediterranean. The Tyrrhenian Sea. And as you can see for yourself, the vast majority of lightning is over a water body. Here is some on land, and here is more over the seas. And then we have some at the coast, which is not a surprise because it rises the landscape. But I bet this is the Marsili Seamount. And it's also quite much about the electrical conductivity of the ground itself. Here we have Campi Flegrei, and this is Vesuvio. Vesuvio didn't got hit by lightning. Now it seems. But Campi Flegrei. So we are in Naples. I want to show you the Vulcan app, what's there. Naples. Some might have heard of Pompeii. If you haven't, you probably should read something about it. Vesuvius, stratovolcano dormant. And Campi Flegrei, Phlegraean fields. The burning fields. So we really should keep an eye on those. 700 years ago, it erupted last time. And where is it? Marsiili Seamount. This. No, it's actually this, I guess. Is it? I'm not sure. No, this one it is. Dormant approximately 5,000 years ago. Maybe 6. Maybe Noah knows something about that. And yesterday I probably figured out why Noah put out a crow first, which isn't mentioned after that anymore. And after that, he puts out a pigeon, which brings back a branch of a tree. And I might know why he used first a crow and why it didn't came back. Yeah, but I leave it here. Thanks. Bye.